Welcome to Kubernetes SIG Apps for Monday, March 4th, 2019. I'll start by putting the meeting minutes in here. We actually have a pretty light agenda today. That's the meeting minutes. The first thing, hi, my name is Matt Farina. I'll be chairing today's meeting. I'm not sure, oh, Adnan is also here. He is one of the co-chairs and he'll be helping out. Thank you, co-host. And today's meeting, we'll start off, we've got two announcements. One is in 1.16, we're going to start removing some old components, and it looks like it's going to start with extensions v1 beta 1. So if you are using those in your Kubernetes resources, and here we talk a lot about workloads, you shouldn't. You definitely shouldn't. I know there are a number of folks who actually still do create new ones with that out of habit and tooling that do it. But as of 1.16, we plan on no longer accepting those to the API. So this is another one of those fair warnings. Use the release version, apps v1. Use things like that instead of the very old extensions v1 beta 1. The second announcement is code freeze is this Thursday, the 7th. And so that's for the 1.14 release. So if you've got something that needs to be in, be aware of the timetable. And those are the two announcements. The next thing that we have up is a demo. Do we have somebody on from, Formast to give us a demo today?
Myself is
Yeah,
here.
we're here.
All right. Well, the floor is yours. You should be able to screen share and go ahead and show us what you got.
Absolutely. All right. Yeah, so you guys will get to hear from me 2 weeks in a row. I'm Dave. I shared Cutlass with you last week, but wanted to share another project that I've been working on with you. I have another of my colleagues, Ping here. Ping, I just turned the camera towards you. All right, so we'll jump into sharing a little bit about the project. Actually, I guess I'll present through the demo and then you can pick it up from there.
Yeah.
So we're going to give a quick demonstration. Well, overall, Formast is a application health monitoring service specifically built for infrastructure deployed in Kubernetes. We're going to go through a pretty simple use case of an example, along the lines of you deploying a new service or a new version of a service, and suddenly there being some error in that. In this case, it's going to be an error that causes all service responses to return with a 500 error. And certainly the goal of the project is to minimize the time to discovery and the time to recovery for these sorts of erroneous states that we can find ourselves in. What we're going to see in the demo is the remediation strategy of automatically rolling back, but that's something that will be configurable as well. It'll just work well for this demo. Let's see, actually, Ping, do you have a good sense of what we want to share on this slide?
Yeah, this is why we need a Formast. Formast can doing monitoring, which is collect the real-time for golden sun metrics from the application, and also we can analyze the logging and the tracing together, which give observability of the application health status. So we leverage this can apply to the deploy time, especially during the convenient deployment and A/B test and also incremental deployment. All these use cases are fit Formast is here to fit for all these use case. So pretty much we have collect all this tracing, logging, monitor information for.
Okay. Yeah, and I think this is one of the overview slides we may jump back to later on. Okay. Yeah, and let's see. So we've got a kind of an architectural diagram as well. I think the most important things to highlight here are the green boxes. These are the portions of this overall architecture that are pieces that we've built out. The Formast project is broken down into at least 3 or 4 sub-projects. Brain, which is the AI machine learning component to ingest the log data and other monitoring metrics data and make decisions around when something has gone wrong in one of these services. The ForMass service is essentially it's the API that the dashboard that we're going to be looking at uses, and it's kind of the central piece of the whole ForMass project. We've got ForMass Barrelman as well. This is a component that actually gets deployed inside of the Kubernetes cluster that you're monitoring, and it has the ability to not only grab some of the data from the applications that we're looking at, like these three down here, the Java, Go, and other Java application that are in this architectural diagram. It also has the ability to trigger remediations, rollbacks, and modify the state of the cluster.
Yeah, actually, ForMass Barrelman is sort of customized like a controller. It watch all the deployment, like I say, architecture. So once deployment happen, it will trigger the service to the ForMass service. So ForMass service itself will save the like a response back, like the the status of the the monitoring request. So ForMass Barrelman is one of the a key AI engine, which is collect application for golden sun metrics or application customized application metrics, and use a machine learning algorithm to detect if there's any anomaly or not. If then feedback return back the service to ForMass service, and then ForMass Barrelman will periodically check the request monitoring request if there's anything unhealthy happen. So it will either trigger the alert or roll back the deployment.
Okay, great. Yeah, the other thing I think maybe worth highlighting in this diagram is that we've got a couple different metrics, data stores, and systems that we either can work with or are planning to. Right now, we have ForMass working well with a Prometheus data store for metrics data. I think it's also the case that we are at least currently working with respect to Cortex. And
yeah,
I know
Cortex is more like you can thinking about Prometheus as a service. It's kind of a centralized, Prometheus is, Prometheus can sitting on the different Kubernetes clustering. Cortex is centralized one, which is serve all the query purpose. So, and also we also support a wavefront and other metric system as well.
Okay, yeah, that's important to highlight, especially since that was some of the early feedback we've been getting so far about the project, is that a lot of people already have their metric data in Wavefront and they have some of their dashboards in Wavefront, and so that's definitely an integration that's going to be important for our project moving forward. So today we're going to look most directly at the dashboard because there's a UI component to look at, but we'll talk a little bit more about where the brain and Barrelman come in throughout that. This is just a slightly more detailed view of what demo we're going to show here. First, we're going to start off with an extension to kubectl, a watch command to tell the system to start ingesting data for a particular application. From that point on, that service is being watched. We'll go ahead and do a deployment, which will be emulated with a kubectl replace with a different file. That version, as I mentioned before, is going to have some errors in it. So we'll see the error rate spike. The anomaly hopefully will be detected, and we'll see that roll back. So this is just one more quick overview of roughly what we're going to see here in a minute in the demo. So let me jump to that. All right, and before even, I guess, starting the demo, I'll give a quick overview of what we've got going on here. This is a custom-built dashboard, though it's, like I said, we're talking about about Wavefront integration, though we definitely knew we needed at least a little bit of a custom-built dashboard, to support the open source use cases as well. So what we have here is for a particular namespace and application, we are tracking 4 different metrics. We've got 500 errors, latency, response latency, CPU, and memory utilization. So right now, so the blue series is the measured series. The green series in the green range, that's our model's expectation for these data series. And so as we see right now, everything's within the model expectations. And that's what we'd expect for the first version that we have deployed. Down below, we've got this kind of, well, we've got a 3D chart. This is kind of more just like an open space that we're playing around with different things. We know that there might be value in having the ability to look not just at with respect to time, but have the observability of things like latency versus error count, in the sense that maybe we see scenarios where the error count spikes when latency spikes, and maybe there's other scenarios where we see the error count is spiking without latency spiking. And so that might indicate to us that there's two different scenarios that we need to look at more closely, two different situations we might need to watch. So with that, I'll just kind of move this down because we're not going to be looking at it too closely beyond that. So let me pull up my terminal window. So the first command I'll run is this watch command. Oops, I think I am connected. I don't know why it said that I wasn't. Interesting. I think I just did this. But just to make sure that this is all going to work as smoothly as possible. I'll make sure that I'm well logged in here. Yeah, I'm not sure what it's complaining about there, though the majority of what the watch command is trying to do is still seeming to happen. So truth be told, this application has already been watched. That's why we have the model data. But just to show quickly how straightforward the process of getting the watching started can be. So beyond that, we're going to take a quick look at the current state of our demo application in this namespace. Okay, so maybe I am going to get tripped up here. Let me see if I can quickly understand what it's complaining about. It looks like I'm on the right Wi-Fi network.
Yeah, I just want to mention why we need this watch command. Watch command is optional. So actually we support both continuously monitoring and also like a monitoring as a service request.
Yeah, thanks, Ping. Let me see if sorry for the delay, guys. Let me see if I can get this to a happier state. We're in the building, so I should be fine connecting to some of the infrastructure we have deployed here, although it seems to think otherwise. I'm trying to connect to VPN to see if we can get around it that way at least.
I understand how these things can go. I've actually been through similar circumstances before. So
yeah, no, you got to always watch out for the demo gremlins.
The demo gremlins and having to deal with networks versus VPNs versus routability to assets. I've been in your shoes before.
Yeah, well, thanks for saying that. I wasn't expecting it this morning since I just run through this a few minutes back, but let's see if it's happier now. It might not be. I truly don't know what it's upset about here. I'm definitely on our network. Well, let's see. Let me try one more thing and then I'll flip to some.
To the video.
Yeah, I think we might somewhere have a video, but actually what I was thinking,
here's what I was, older version of.
I don't know that I have a handy thing, so here's what I'm going to do instead. This is going to be much less exciting, certainly, but yeah, time to actually.
We have a formaster.io. Maybe we can.
Yeah, we'll see if the website is valuable to flip to in a moment. What I want to do really quick is just open this up real quick. this is just the duration of time that we're seeing. And as I mentioned in the charts, that is, and as I mentioned a moment ago, I had run this before. And so within the last 45 minutes, so we'll get to see that here, but it's obviously not as exciting as seeing it happen in front of our eyes. Let me keep playing a little bit more. Okay, now, all right, well, this demo might be coming off the rails. I'm sorry about that. What are they complaining about now? Now the data is not even loading. Do you happen to know, Ping, if you have the video handy? Because I'm not sure that
yeah,
I do.
I think let's probably go to the, like I say,
Definitely go to
HTTP
formats.io. So this is,
formats.io. Yeah.
I think we would have been getting to this by the end of the presentation.
So
but
I think there's, let me quickly check. Yes, I do find like a video, but it's even though out of date one, but at
yeah,
least it's not that
nothing,
fancy anymore.
Let me try one more time here to see if I can at least just get the deployment triggered. And here's one more thing I'll do. Is maybe there's something wrong with that terminal window.
Okay. Okay. Yeah. We go to the.
Oh, okay. I don't know what that means, but for whatever reason, my first terminal instance was seemingly unhappy maybe. So this time it looks like the that redeployment triggered the change, though as we were seeing, we weren't getting data. I think that's because I did flip over to our guest network and on VPN. Can you guys hear me again?
Yeah, I turn on.
Yeah, we can hear you.
Okay. All right, there we go. Data coming back in, and all right. I think this is going to work for us finally. So we do get to see from a few minutes back the scenario that I had tried before. Actually, now that I have it seemingly working, let me flip back to just the last 15 minutes so we get to see the data at a finer granularity that will look a little bit better. All right, so I had just triggered the version 2 deployment, and so I think looks like it's starting because some of our data application metrics start to trail off. We don't have the latest data points from some of those. But we do see, so first off, we've got an annotation of the different version changes that this dashboard is able to show us. We see that the 500 error count has indeed spiked. We're still, some of the latency data takes a little while to come through. It looks like there's probably been a version remediation back to V1. And I think we'll see in a moment here where the classification engine, the formats brain, recognizes that this point right here was the anomalous data point that triggered the version rollback. So, you know, that is the scenario I wanted to show. I'm sorry it took a little while to get to that point. But I think that's the majority. Let me quickly flip back to the terminal just to show as well. What I didn't show was what the version was as far as the kube described deployment was. It's probably not even worth doing now because it's back to version 1. But what we would have seen is that it had indeed flipped to version 2 and flipped back to version 1. That was just kind of to show in another way that the demo is behaving as we'd expect. So that's the majority of the demo. I'm going to flip back to our presentation now and open the floor a little bit more to Ping. Is this where we want the slide, the Q&A? Or did you want to go to this one first?
Yeah, this, So, you may question about what's the AI model we leverage. So this page is tell you like, we have a different algorithm for different use case. For example, for the Canadian deployment, we have all the algorithm, the peer-wise, the analyzed algorithm on the left side. But for post deployment or continuously monitoring, we use the right side of algorithm. Some of the algorithm is for stability, time series data. Some of the algorithm is for the seasonality model. And if we come with the multivariant use case, which is we support 4 golden sign metrics. For example, CPU memory, which is the saturation and the latency error, and the transaction per second metrics. We can leverage the a deep learning LSTM. So that is overall just this page just tell you what machine learning algorithm formats to leverage.
Can you remind me as well what the bolded lines were here?
This is the default one.
Default algorithms used. Okay. Yeah. Great.
Yeah, user can overwrite,
Yeah. So let's see. I think we are able to open the floor up to any questions now. I should have said from the outset, please jump in if you have any as we go. Along the while, I'll also flip to our GitHub pages, but I want to open the floor first to any questions you may have. All right. Certainly keep thinking if you have any. I'll just kind of scroll through our website here, which is just kind of an overview of, actually, I guess this diagram I don't think is in our presentation right now, but it's a,
no, it's a appendix.
It's in the appendix maybe, yeah. Okay. But this is one that just kind of at a high level describes as well the ingestion of metrics logs and traces, roughly where ForMass sits, and then some of the remediation strategies that can be taken from there. Yeah, that's probably what's worth highlighting there. And then, of course, this, if I didn't mention it up front, this is a fully open source project that Intuit is sponsoring or stewarding. I'm not quite sure what the term is, but it's what we get to work on most of the time, but it's fully public. So it'd be great if you wanted to take a look, star our project, take a look at our issues and pull requests. And of course, we'd always love if anybody wanted to get involved and contribute in their own way.
So ForMass project have two repo. One is the ForMass, another one is ForMass Spring.
That's right. Yeah.
ForMass Spring is basically use the pipe. Okay.
Is it? It's definitely inside of the.
I think it's a typo.
Okay, maybe it's.
Yeah.
We'll make sure that that's correct in the slides that we share.
So basically, it's the one which is apply the AI model to analyze the health of the metrics and then return the anomaly back if yes, there is. Any question?
And
all right.
If not, like I said, I'll go ahead and share. We'll share the slides here shortly. I'll probably post that in the conversation channel. And thanks again for bearing with me through some of the technical hurdles there. Glad we were able to get to a point of actually showing something.
Yeah.
No, thank you. This was great getting to see this work. I couldn't think of any real questions because most of the ones that I came up with you answered along the way. Okay. And some of the other stuff I know I'll come back to. It really reminds me a little bit of things like automated run books with remediation based on some machine learning, which I appreciate. And the ability to do things like rollbacks or find problems. That's entirely useful. So I'm going to go poke around more at this. Thank you.
Yeah, much appreciated. Thank you.
So the next thing we have up is we only have one discussion topic, so if you have more, feel free. And I expected this one to be rather light and more informational. Where's today's day? The customized folks are adding generator plugins via a KEP, and I know that we are folks who tend to use the tools here and dig in and have opinions on how to build them. And so I wanted to point out this KEP that is coming along, and I'll share my screen real quick. There's been a bit of feedback on it, but really this was more just informational sharing than anything else to talk about it. The current path, I believe, is Go plugins, but there has been discussion about that because it doesn't do things like support Windows. What I would ask here is folks who are interested to go have the conversation over there more than anything else. But this is one of the things they're looking at, customized secret generator plugins. I don't know if anybody had any thoughts on this or not. I'm not exactly sure how this plays into the customized that's in Kubernetes SIGs versus the customized that was merged into kubectl, because there are some differences there, and I'm not fully aware of the differences, but there are folks who are diving into this, and app developers wanting to dig in to use customized, this applies to you. That's all I really had on this. Did anybody have anything they wanted to do on this or any form of open discussion? We may have a short week. Silence, going once, going twice, going 3 times. All right, we are done for the week. Thank you all for coming. You can have about 29 minutes back. Have a wonderful week. We'll be back here next week to talk about the Workloads API. Thank you all.
Thank you so much.
Yep, bye-bye.